question 11. And question 11 states, write the Maclaurin series and the interval of convergence for each of the following functions. So you have a is equal to 1 divided by 1 minus x. And here I just quickly added letter f. I forgot to add this e there. So anyways, or this tan, this inverse tan of x there. So anyways, so part A is 1 over 1 minus x. Part B is e to the x. C is sine x. D is cos x. And then E is inverse tan of x, or the arctan of x. And then F is ln x. Actually, I typed this wrong. The question was actually ln of 1 plus x. Like that. Yeah, it wasn't just ln x. So it was actually ln 1 plus x. So now let's take a look at the solution. Alright, so the solutions for all parts A to F. So recall from the same video above, and let's see, the furthest link is just right over here. So this Taylor and Maclaurin series. So we're asked for the Maclaurin series, so that's just a Taylor where A is equal to 0. Yes, so notice how all these x minus A is 0, so you just have x there. So yes, that is the Maclaurin series like that. And here's teleported above. So here's the Taylor series, so x minus A. And then the Maclaurin A is equal to 0. So then you have x to the power of n as opposed to x minus A to the power of n. Anyways, let's just dive right in. So this is from that same video. And here is part A. This is 1 over 1 minus x. So 1 divided by 1 minus x. The Taylor series, or the Maclaurin series here is summation from n equals 0 to infinity of xn. So you're going to have, when you plug that in, so when you have n equals 0, so x to the power of 0 is just 1. By definition, and then plus right here x to the 1 plus x squared, x 3, etc. And then the radius of convergence is 1. Yeah, so x has to be absolute value of it less than 1 there for this radius of convergence there. And now part B is e to the x. So here's e to the x. So e to the x equals to the summation from n equals 0 to infinity of x to the power of n divided by n factorial. So you're gonna have 1 plus x divided by 1 factorial plus x squared plus divided by 2 factorial, etc. And the radius of convergence is r is infinity, so converges for all values of x. And now the next one is sine of x. So sine of x is written right here. So summation from n equals 0 to infinity of negative 1 to the power of n times by, then you have x to the power of 2n plus 1 divided by 2n plus 1 factorial. So it looks like this. So it'll look like x minus x cubed over 3 factorial, so it skips 1 each time, so then plus x5 divided by 5 factorial, then a minus. It's alternating, and you're going by odd powers and odd factorials. Alright, and now let's take a look at the cos one, so the cosine x, bar D, that's this right here, so it's again this alternating, so it's similar to the sine one, so the summation from n equals 0 to up to infinity. This is a negative 1 to the power of n, so it's alternating series, and then x to the 2n as opposed to this odd 2n plus 1, and then divided by 2n factorial. So you're going to get a 1, so this could be viewed as x to the power of 0 as even, and then subtracted by x squared divided by 2 factorial, then you have a 4, and then 4 here, and it's alternating as well, so minus plus, and so on. And the radius of convergence is also infinity. And now the next one is E is tan, inverse tan of x, or inverse tangent. So you're going to have over here summation from n equals 0 to infinity of negative 1 to the power of n. And then this is going to be x to the 2n plus 1 divided by 2n plus 1. But it's not factorial. So this is exactly the same as the sine. Notice here's exactly the same. Everything's the same except this is not a factorial. It's not a factorial in there. So there's no factorial there. But those ones are factorials, which is quite interesting. And the radius of convergence for this is 1. So not infinity. These are infinity, this is 1. Alright, then now the next one is ln 1 plus x that we're asked for. This one also has the binomial set up over there. This is 1 plus x power of k. But here we're going to look at this one here. Ln of 1 plus x equals to the summation from n equals 1 to infinity of negative 1 to the power of n minus 1 times x n divided by n. Yeah, so this one is going to be x minus x squared divided by 2 plus x cubed divided by 3 minus x4 divided by 4. So this one doesn't skip any odds or evens. This goes every single term, but it's divided by and it's alternating over there. And the radius of convergence is 1. All right, and just a note here. So note that the above image includes the power series for ln 1 plus x, which is from the 7th edition of my calculus book, while the 6th, which I used for my previous video, did not have it. So this wasn't in the table right here. This wasn't in it in that video. But however, I went over ln 1 minus x in a later video. Here's a link to it. So again, this is a power series video. This was part of example 6. Just to illustrate here. So find a power series representation for ln 1 minus x and its radius of convergence. And I showed that going over a bunch of steps here and basically solved it over here. So ln 1 minus x equals to negative x minus x squared divided by 2 minus x cubed divided by 3. So they're minus. So these are all minus. And then it basically equals to negative summation from n equals 1 to infinity of this is going to be xn divided by n, and where the radius of convergence is 1. So absolute value of x is less than 1. Yes, you have r is equal to 1. So that is for 1 minus x. So just for completeness, let's just solve the ln x. So note that we can replace x with negative x in the above ln 1 minus x power series to get the power series for ln 1 plus x. Yeah, so we could basically just manipulate that and get it. So what we'll have is ln of 1 minus, and then this is minus x, so if x is that instead, and we can just plug that inside the power series. Oops. Yeah, so this is going to equal to negative, so this one right here, so negative x, and then we're going to have a negative x squared. If you put a negative inside, that's just going to be positive anyways, so you can just leave that. Or you could just, for completeness, put it in there as well. Negative x squared, and then minus negative x cubed over 3, and then minus plus, dot. So this happens is this one's going to be positive. So equals positive x. This one is negative x squared. Anytime you have an even power, it doesn't change. It's going to be a negative x squared. It's going to be positive there. So notice these ones are all negative, but now every odd, because you have a negative there, so negative, the power of a odd number there is going to be negative, and then negative times negative is going to be positive. So this becomes positive x3 over 3, and the next one's going to be negative x4 over 4. The next one's going to be plus next one's going to be plus x5 over 5, etc. And then it's going to be negative plus dot. Yeah, so we have this right here, so it's going to be alternating, and yeah, we could write it as this form over there. This is, yes, notice the exact same thing here. So x minus x squared over 2 plus x cubed over 3 minus x4 over 4. So the evens are negative, the odds are positive. And right here, yeah, notice this becomes, when you put in the negative there, those cancel. That's just the same thing as ln of 1 plus x. So this equals to this over here. And now if you write it as a formula, as a summation formula, we get the summation. Let's write this over here. Summation from n equals 2. Well, let's start. This one has a power of 1. Then let's just start with a power of 1 up to infinity of, and then this is going to be, it's alternating. So we're going to have, let's go with negative 1 to the power of, well, we could just do the same thing as the one listed in the table. So n minus 1. So if you plug in 1, that's going to be power of 0. It's going to be 1. If you plug in 2, it's going to be 2 to the 1. 2 minus 1 is 1. So negative 1 to the power of 1 is negative. It's negative and alternates every single time, and then this is going to be xn over n, like that. So there it is. That is our, and I'll put this here for completeness, ln 1 plus x. Like that. There is our formula. And this is double check. So this checks out. It's going to be negative 1 over here. So this is ln 1 plus x is equal to the summation from n equals 1 to infinity of negative 1 to the power of n minus 1 times xn over n. This equals to, again, x minus x squared over 2 plus x cubed over 3 minus x4 over 4. And radius of convergence is 1. So it's the same thing. Because these are basically the same formulas. We're just switching that variable.